Hello, hello. Okay. My mic is working now. Well, welcome to sunny Colorado. Here we are, another ETHDenver. So my name's Mark, and today I'm going to be talking about some design decisions shaping L2s. So we're going to get into the why rather than the how, right? So user stories help solve real problems. I'm here today to talk about the actual user problems that we're trying to solve with the blockchain. You know, we want to move away from just talking about the technology as this solution and really think from first principles from the perspective of the user and the problems that are being solved. So let's start off with talking about user stories. So a user story is a description of a software feature articulated from the end user's perspective. It focuses on what a user needs rather than the technical details. So this is the important point. In Ethereum, we love to talk about the technical details. But here, when thinking in terms of user stories, we want to focus on the user needs. We want to solve real problems for real users. So how do we formulate a user story? As a who, I want what, so that why. This is like a very simple template for how to make a user story. And doing this will help to make sure that the technologies that you're working on are framed in solving problems for end users and not just an interesting idea to work on. So, first thing we want to do, we want to define our user. This is one of the most important questions for any startup. So for simplicity, we're going to say today, our user is any entity with an on-chain asset. Now I'm going to walk through some value props and some user stories. And we can, from there, talk about the design decisions for the OP stack or blockchains in general to really hone in on how these problems are being solved. So, censorship resistance. As a user, I want to be able to guarantee that I can include a transaction so that I can maintain the ability to exercise property rights over my assets. So why is this important? For example, you might have a loan in DeFi and you want to keep it collateralized when there's lots of volatility. You are at risk of losing your money to a liquidation if you cannot land a transaction on chain, right? This is very important, this censorship resistance property. So thinking in terms of the OP stack and L2s, there's this idea of force include transactions. So there's basically two ways to include a transaction into an OP stack based L2. You can either go through the force include path, which is a little bit slower, or you can go through the direct to the sequencer path, which is a little bit faster. Everything comes with trade-offs. The slower path, the force include transaction path, that goes through L1. So that guarantees the censorship resistance properties of L1. If you go directly to the sequencer technically can censor if they want to through the low latency path. But ultimately, the only power that the sequencer has in this case is the ability to delay the inclusion of a transaction. They cannot completely censor any transaction. And we saw this play out in practice with Sonium. So Sonium had this policy where they wanted to protect user IP rights through their sequencer. So they did not want to include any transactions that would infringe on those rights. But it's possible for anybody to, go through L1 through this force include transaction path and get their transaction included. And you can see the L2 Beat team here actually did this in practice, and they were able to, you know, touch these tokens and trade them that the sequencer was not processing transactions for. Okay, next user story. We're going to talk about hardness. So as a user, I don't want the rules of the platform to change underneath me in a way that is not aligned in my interests, so that I can rely on the platform in life or death situations. Right, this is one of the promises of the whole crypto and Web3 movement, is there are these existing platforms that can kind of just change the rules arbitrarily, and you don't really have any say in it. So this property of hardness lets you understand the way that the platforms or your counterparties are going to act and have transparency into that, so that you can rely on them more. And you don't need to worry about, say, being deplatformed or the platform no longer changing its rules in some way that isn't aligned with you. So this is why the roll-up stages framework exists. We have this idea of a stage 0 roll-up, a stage 1 roll-up, and a stage 2 roll-up. So a stage 1 roll-up has a forced 7-day delay on upgrades, while a stage 2 rollup has a 30-day delay on upgrades. So what this means is if the chain is changing its rules in a way that you don't like, you have time to exit the chain and go someplace else. Now, people often ask the question, you know, can't the sequencer just arbitrarily change the rules? This is not the case. The only way that an OP stack chain can change its rules is really if the proof system is upgraded on chain, and it's really like this social consensus around like who's running the full nodes. Like the sequencer does not have the unilateral ability to just arbitrarily change the rules and push them on their users. The old chain will still live on, and the bridge will still basically allow for users to withdraw from the old chain. It will not follow the new chain. Okay, so let's talk about medium of exchange. As a user, I'd like to send my on-chain assets to purchase real-world goods with as good of a UX as a credit card, so that I can rely on blockchains for everyday expenses. Right, this is like a real everyday sort of use case for blockchains. The reality is that, you know, we cannot finalize blockchains basically instantly. There's trade-offs. So we have this idea of levels of finality. People talk about pre-confirmations, right? For an optimistic rollup, finality of the chain happens as soon as the batch data is posted to L1. A lot of people seem to think that for an optimistic rollup, the chain doesn't finalize for 7 days. That is not true. The chain actually finalizes as soon as the L2 transactions are posted to L1 to, you know, the DA layer. All right. So let's talk about liveness. This is basically the chain staying on. So as a user, I would like to not rely on the uptime of a third party so that I can always rely on my on-chain assets. So what this means is if the sequencer goes down, the chain stays live, and you can continue to talk to it and interact with it through force include transactions. You don't need to worry about if the sequencer is online or offline, but we have this idea of like the sequencing window. Basically, if the sequencer does go offline, you will definitely experience a large quality of life degradation with interacting with the chain. It'll be much slower, but you can still interact with the chain and get your assets out. So yeah, there's actually a UI that enables this. If you go to bridge.gg you can arbitrarily interact with any L2 contract directly from L1. So now let's talk a little bit about MEV protection. So as a user, I'd like to transact without being worried about being sandwiched so that I don't leak my value, right? This is a major problem on L1 where, there's like Jared from Subway who sandwiches users and they make a lot of money doing this. It's the dark forest. So with the OP stack, we have this idea of a private mempool where only the sequencer can learn information about the pending transactions. This prevents malicious actors from going in and, extracting MEV from the users. Now, there's a trade-off here because technically now the sequencer can extract this MEV, but it's possible to run the sequencer in a TEE, a trusted execution environment, and basically prevent this, because the whole thing with the TEE is you can basically say, this is the exact block building algorithm that I'm going to use, and anyone can verify that I'm running it, and anyone can go and look at exactly what it does. They can run it locally, they can play with it, and they can see that it does not extract malicious MEV. So it's a good trade-off. Now, write costs. So as a user, I'd like my fees to stay consistently low so that I'm never priced out of being able to exercise the property rights of my on-chain assets. So this is why we're working on horizontal scalability through Interop. In Web 2, they have this architecture where you can horizontally scale your application in the cloud. In crypto, that's just not possible. People are still deploying single server applications on a single chain, right? We need to evolve past this and start to develop applications that can horizontally scale across many chains. This is why we're working on the cluster architecture in the OP stack. Cool, so who else are our users? App developers. Let's talk about app developers. So with the OP stack, we really care about EVM equivalence. As an app developer, I want the Ethereum tooling to just work with my app deployed to L2 so that I can focus on application development instead of rebuilding my tooling stack. The idea is that you never really want to surprise developers building on your platform. You want it to work the way that they expect. So by focusing on ensuring tools like Foundry and Hardhat just work for OP Stack, by avoiding introducing extra precompiles or large modifications to the EVM, it makes it a lot easier for developers to just build their app and ship it and use all of the same tooling that the wider L1 Ethereum ecosystem has built to ensure that their application is safe. So in the context of interoperable apps, as an app developer, I don't want to have to worry about complex interop details so that I can just focus on my application logic. So the solution here, make cross-chain calls as similar to calls within a single chain. Make them as similar as possible. So what does this mean? We want to build tooling, like a library, that you can just drop right in. And from the developer's perspective, it'll be literally no difference than just calling a smart contract on the same chain. Cool. That is it for my talk.